know. Yeah, I think I edited you. Yeah. Girl, okay. Okay. I was wondering if I know what I like that. We only have to call tomorrow at 1 p.m.
So it's funny, when you ask me that question, you ask me about
Evo, oh, I see. Yeah.
Anna Perry in here. Kelsey Beckett. Maddie Gillen. Sophia Lenz. And Anna Perry.
Yeah, no, I thought that was. I was like,
All right. With the homework that was due last night, one problem seemed to cause people fits more than any other. It's problem number 20. And in approaching, and I got a lot of Ask the Teacher requests on that one. In doing that one, I would refer you back to example 6 in our lecture notes, where we had to graph these different equations. And in doing the transformations, right, we would start with the basic equation, and then we would do one transformation at a time on that equation until we arrived to the equation we got a graph, okay? And so in doing problem 20, I would encourage you to do the same thing. Okay, and start with the basic equation, y equals x squared, and then perform the transformations on that equation one at a time until you get to the final equation. And so the first thing you got to do is shift that equation, in this example, left. Now everybody, you see the numbers in red, right? That's the part that gets changed from one student to the next, right? So not everybody's just copying the answers down. So in this example, you got to shift left 2 units, and you know to do that, you replace x with x plus 2, right? Then the next thing we're going to do is shift down 5 units. So to do that, right, take this equation and you subtract 5 from it. Okay. Oh, I did that out of order. My eyes dropped down too many lines, right? We go left 2 units and then we reflect across the y-axis. I'm sorry. So I went from the first transformation to the third. Reflect across the y-axis, you replace x with minus x, right? So y is equal to minus x plus 2 squared. Okay. Now we shift down 5 units. By subtracting 5 on the right hand side. Okay. And now the vertical scaling by a factor of 4, right? So, right, if we have the function y equals f of x, and we multiply it by a constant c, right, that's vertical scaling, okay? So, and if c is greater than 1, right, that's a stretch. If c is between 0 and 1, that's a compression, okay? Well, we're going to scale by a factor of 4, so we have to multiply the entire right-hand side by 4. Not just this first term, the entire right-hand side, right? The entire function gets multiplied by c over here, right? So we have y is equal to 4. So I got to put parentheses around this. Right, so I got a second set of parentheses. 4 times minus x plus 2 squared minus 5. Okay. What a lot of people were doing is they were multiplying just minus x plus 2 squared by 4 and leaving the minus 5 alone. But you got to multiply the entire right hand side by 4. Okay. And then reflect across the x-axis. You take the negative of the right hand side, right? Which is multiplied by minus 1. So the minus 4 this should be your final answer. It's on the right hand side, okay? Except they have g of x, right? So g of x is equal to that, right? Replace y with g of x. Okay. That was an interesting problem. Okay. Yeah. So most people sort of got down to here, and then when they did the vertical scaling, they put the 4 out front of this left parentheses. You got to multiply the entire right hand side by 4. Okay. And then you're all set. Okay. So if you didn't get 20 done, need some more time, you should send me an extension request. Right, and I'll give you another 24 to 48 hours to finish this up. Okay. All right, any questions on that? All right. So yesterday, right, was a very productive afternoon after my last class. My last class ends at 2 p.m. or 1:50 on Monday, Wednesdays, and Fridays. But between all the students that came to my office and getting ready for today, finishing today's lecture, and starting 2.4, right? The last express bus leaves at 7:45 at Chick-fil-A, and the time clock. Oh, I had printing issues. I had a hard time getting the next set of notes printed out because it wouldn't staple. And so I had to take them home and hand staple them after. So I had to do this for 3 sections, not just this class. So anyway, the time clock, game clock expires at 7:45. That's when the last bus, that's the express bus, leaves the Chick-fil-A. And so I just didn't have time to get the quiz typed up and printed out. So I'll do that tonight. And then we'll take it tomorrow. The other thing is homework 2.3. I plan to get that made up tonight. And then that homework will be due Monday night. So, you can be on the lookout for that. All right. Any questions or concerns? Is there anybody who needs the 2.3 notes who was playing hooky yesterday? No? Okay. You didn't? Okay. All right, so we're learning all about linear equations. Linear functions, okay? And so yesterday, we ended top of page 3. And we had done part A only, right? So we had come up with this equation relating temperature to the number of chirps that crickets produce, right? And so in part A, we had T is equal to 0.2 times N plus 47.4. Correctamundo? So N is the number of chirps and T is the outdoor temperature, okay, or the temperature anywhere. In B, it says if the crickets are chirping at 120 chirps per minute, estimate the temperature. Okay? So, you know how to do that. You just put in 120 in for N on the right hand side. So 0.2 times 120 plus 47.4. Now it's just arithmetic. We have temperature is equal to 71.4 degrees. Okay. So you're out in the woods, you don't have a thermometer, the crickets are chirping, count the number of chirps per minute, plug it into the equation, and you know what the temperature is outdoors. Right. Okay. That's kind of what that's telling us. Okay. All right. Any questions on that? All right. In problem 6, cost functions, right, in economics are often written as linear equations. So in example 6, you're given the manager of a furniture factory finds that it costs $2,220 to manufacture 100 chairs in one day and $4,800 to manufacture 300 chairs in one day. Assuming that the relationship between cost and the number of chairs produced is linear, right? So this is where we have a linear function. Find a function that expresses the cost of the chairs as a function of the number of chairs produced, okay? So cost is a function of number of chairs produced. So we can let X equal number of chairs produced. Then C of X, right, because we're coming up with a linear function, so C stands for cost. C of X is the cost of X chairs produced. Okay. So our function, right, is going to have the form C of X is equal to mx plus b, right? Slope-intercept form. Okay. Now, we're given 2 data points. Okay. So remember, X is number of chairs produced, that's the independent variable, right? And then Y, right, will be cost of X chairs produced, that will be the dependent variable. Yes, ma'am?
How do you determine which one is independent and dependent? Like when setting up like.
Well, independent is, goes into the function. Dependent is what comes out.
But like
So-
making like x1, x2, and y1 and y2, how do you determine which one to put in for like the actually the coordinates? Like how do you know which value, like the chairs produced or the cost is x or y?
Yeah, that's a very good question, right? Because you can get it backwards, right? So, X is the independent variable, right? When we write an ordered pair, X, Y, right? Or write an equation, Y equals, right, X squared plus 5X minus 7. X is the independent variable, right? It's on the right-hand side. Y is the dependent variable. It depends, Y depends upon the value of X, okay? So, it matters how we write these ordered pairs, right? The first number is the independent, second number is the dependent. The way we're setting this up, cost depends on X, number of chairs produced.
Okay, that makes sense.
So, in the first example, right? Because my inclination was, I'll be honest, was that I wrote these things down backwards.
I did that too.
It's easy to do that.
So what if it was, profit of chairs, not cost, like what if,
So you could have a profit function.
so it'd be like the other way around?
No, I know you could have profit is a function of number of chairs produced, right? So you could have P of X, right? So you still got X as the independent variable. So the first data point we're given is that X is equal to 100, right? 100 chairs produced, X is the independent variable, right? It's the input variable. And when you produce 100 chairs, you have a cost of $2,220. So this is like X, Y. Okay? You have a question, Mr. Serpa?
Just something that might help people, on these equations, whatever it says it's a function of, that's basically your x. So like the previous question, like temperature is a function of the number of church, your function is the number of church, that's your x variable, temperature is your y. So this one where it says the chairs are a function of the number of chairs produced, or the cost of chairs are a function of the number of chairs produced, the number of chairs produced is your x, and the cost is your y. So, that's, if that's any easier for you.
Alright, so when X is 100, number of chairs produced is 100, the cost is 2,220. And when the number of chairs produced is 300, the cost is 4,800. Okay. So those are two ordered pairs, right? These are like points in the coordinate plane, and we can calculate the slope of the line to those 2 points. And that'll give us our M. So M, the slope, is the change in Y over the change in X. So change in Y is 4,800 minus 2,220. Change in X is 300 minus 100. 4,800 minus 2,220 is 2,580. And 300 minus 100 is 200. And then when you do that division, you get the slope M is 12.9. So this is the basic form of our function. I'm going to replace c of x with y for a moment. And so now we know that m is equal to 12.9. And now we just have to estimate b, calculate b. And to calculate b, you can use either of these data points, right? Remember, the first number is x, the second number is y. So I use the first data point. So I put in 2,220 for y. 100 for x. And now we solve for b. Okay? So 100 times 12.9 is 1,290. And we get b is equal to 930. So we replace b up here with 930. And then to be proper, right, we should replace y with c of x. That's our function notation. We have c of x is equal to, now you don't have to use c of x. C is the name of your function, but I did, right? C for cost is equal to 12.9x plus 930. And you're done. So that's A. That's our cost function. Okay. In B, it says using this function, find the factory's fixed cost, that is, the cost incurred when the number of chairs produced is 0. Well, we already know the answers, sort of technically, right? It's the y-intercept, 930, that we found here. So all we're going to do is we're going to put in 0 for x. And so the cost when 0 chairs is produced is c of 0, which is equal to 12.9 times 0 times 930, which is just the intercept, y-intercept, 930. So B, we have the cost when 0 chairs are produced is equal to 12.9 times 0 plus 930. Now because I got a decimal here, I'm using parentheses to indicate multiplication, okay? So remember, sometimes we use parentheses for multiplication. We use parentheses to indicate multiplication when we factor, right? When we factor and we have x plus 4 times x minus 2, right? The parentheses are indicating multiplication. Okay. 12.9 times 0 is 0. And so the cost is $930. You might be wondering why the cost isn't 0. That's because even if nothing gets produced, salaries and what have you still have to be paid. Okay. Yes, ma'am.
So why did we only find, so like in example 5, we found point slope and slope intercept form. So why did we only find just the slope, or the, slope intercept form?
I mean, that's the most typical.
You don't have to do both.
You don't have to do both.
Okay.
Now, I did both on some examples because it did not specify.
Okay.
Right? And then I think on one example we did point slope form, and then we rewrote it as slope intercept form, right? But typically in problems like this we write it in slope intercept form.
Okay.
That's typical. All right. So any questions on this? Okay. All right, last problem, example 7. On page 4, write an equation of a line that passes through the point 1 minus 2 and is perpendicular to the line that passes through 4, negative 5, and minus 3, 1. Okay? So we have one line that passes through these 2 points, 4, negative 5, and minus 3, 1. We're going to write the equation of another line that's perpendicular to the line that passes through these 2 points. So the first thing we need to know is the slope of this line. Okay? So this is the slope of the line, right? This stands for perpendicular, right? We're going to find the slope of that line first. And then given that slope, we can find the slope of the line that's perpendicular to it. So the slope of the line that goes through those 2 points, right? Change in y over change in x. So we have minus 5 minus 1 over 4 minus negative 3. So this is equal to minus 6 over 7, right? Which we can just write as minus 7/6. So then the slope of the line that's perpendicular to this line, right? It has a slope that's equal to the negative reciprocal, right? Of minus 7/6. Well, the negative reciprocal, right? Negative negative is positive, and the reciprocal 7/6 is 6/7. So m is equal to 6/7. So this is the slope of the given line. Okay. Why did I flip it? I got ahead of myself. I'm sorry. Yeah. Okay. It's minus 6/7. It's minus 6/7, and then when I flip it, take the negative reciprocal, it's 7/6. Thank you. All right, so that's the slope of the given line. And then this is the slope of the line that's perpendicular to this line. And now, this line, right, the slope of the line perpendicular to the given line, passes through the point 1 minus 2. So we can use point slope form to write the equation of the line that's perpendicular to this line, and then simplify it into slope intercept form. Okay. So we have y minus negative 2 is equal to 7/6 times x minus 1. Okay. So this is point slope form. Well, negative of negative 2, right, is equal to y plus 2. So let's make a note, this is point slope form for the equation of the line. And now we can distribute the 7, 6 inside the parentheses. We have y plus 2 is equal to 7, 6x minus 7, 6. And now we subtract 2 from both sides. So you can see this is shaping up to be slope-intercept form. So we have y is equal to 7, 6x minus 7, 6 minus 2. And minus 7, 6 minus 2 is equal to minus 19, 6. So we end up with y is equal to 7, 6x minus 19, 6. And we're done. Just slope-intercept form. Slope is 7, 6. The y-intercept is minus 9/16. This is slope, intercept. So it did not specify whether to write the equation in point slope form or slope intercept form, right? So both of these should be acceptable. And they both represent the same line. Okay. The graph of those two equations is exactly the same. Okay.
If you wrote for point slope form, like if you just automatically went like y plus 2 equals 7, 6 x minus 1, would that be wrong?
No. No, you could have wrote it that way as well. Yep. Yeah, all you're doing is taking care of the double negative. Yep. Okay. All right. Any other questions? All right, so this homework, right? I'll get it. The game plan is to get it put together after my last class today and get it released in WebAssign, and it'll be due Monday night. All right, so that takes care of linear functions. Now we're going to move on to quadratic functions.
You have an extra one.
Oh, is there somebody who doesn't get one, or do I just automatically? It seems like every week, every time I hand out notes. Do I hand out too many? Maybe I can't count. I handed out 27 copies. Six people, and handed out 25 copies. All right. So now let's talk about quadratic functions. You're all familiar with quadratic equation, quadratic formula. All right. So you're familiar with the quadratic equation in two variables, x and y, right? Y equals ax squared plus bx plus c, right? A can equal 0, because if it equals 0, then 0 times x squared is 0, and all we have is the linear equation. And you know that the graph, the quadratic equation in two variables is a parabola, okay? And the graph of the parabola passes the vertical line test, right? So y is a function of x, quadratic equation. And so we can replace y with function notation, like f of x. And now we have a quadratic function versus the quadratic equation, okay? So in the example 1, right now we've sketched these graphs multiple times already. We'll do it again. So in example 1, we sketch the graph y equals x squared, right, in part A. We've already done this. X and y axis, and the graph is a parabola that goes through the origin. Okay? It's called the vertex, the bottom point of the graph. And when you use graphing software, right, the graph to the right of the y-axis is a mirror image of the graph to the left of the y-axis, right? It's symmetric to the y-axis. In B, got a graph minus x squared. And you know when you put a minus sign, this is y equals x squared. So when you take the negative of the right-hand side, that flips the graph over the x-axis, right? And so the graph in B now goes down instead of up. Vertex is at the same location, but the graph is just flipped over the x-axis. The lowest or highest point is called the vertex. So this is the vertex in A, and this is at the origin, that's the vertex in B. Okay. The vertical line to the vertex is called the axis of symmetry. So in this case, the vertical line through the vertex is the y-axis. So the y-axis is the axis of symmetry in these two examples. Okay. The coordinates of the vertex are easy to calculate, right? From ax squared plus bx plus c. Okay. The x coordinate for the vertex is actually negative of b over 2a, and then the y coordinate, remember y values are dependent on x values. The y coordinate is f of minus b over 2a. Okay? And since this is the vertex, the axis of symmetry is the vertical line, x equals minus b over 2a. So this is the equation of a vertical line. Okay? So in general, when a is greater than 0, when a is positive, right, the parabola, we say the parabola opens up. And this is the vertex, right, the lowest point in the parabola. And that vertex is located, right, its x coordinate is minus b over 2a, and its y coordinate is f of minus b over when A is less than 0, the parabola opens down. Again, here's the X and Y axis. And now the parabola opens down. The highest point again is the vertex. And the vertex again has an X coordinate of minus B over 2A and a Y coordinate of F of minus B over 2A, right? That hasn't changed. Okay? Now, I will point out, right, that the vertical line that goes through the vertex and crosses the x-axis at minus b over 2a, right, that is the axis of symmetry. And so, using graphing software, you will see that the right half of the graph to the right of this vertical line, b equals minus b over 2a, is a mirror image of the left half. Okay? They're perfectly symmetric. Okay? And the same is true over here. Okay? The vertical line that goes through the vertex and crosses the x-axis at minus b over 2a is the axis of symmetry. The graph to the right of the axis of symmetry is a mirror image of the left half. Okay. All right. So you remember when we did the equation of a circle, right? We had standard form. Okay, you had to use complete the square to write the standard form. Well, we also have standard form with quadratic functions. So f of x equal to ax squared plus bx plus c, right? Using the complete the square technique, that on the right hand side can be rewritten as a times x minus h squared plus k, right? That's standard form. And the vertex, when written in this form, is located at the point H, K. So in example 2, we got to find the vertex, x and y intercepts, axis of symmetry, and state the domain and range of the given function. Well, for quadratic functions, parabolas, the domain is always all real numbers. You can tell like looking at the graph, right? In this case, it goes down to the left forever, right? And then it goes down to the right forever here. Right? It's defined for all values of x. So we have f of x is equal to minus 2 times x squared minus x plus 1. Okay. And so in this example, right, you can see that a is equal to negative 2, b is equal to negative 1, and c is equal to plus 1. Okay. So to find the vertex, okay, the x coordinate is located at negative b over 2a. So minus b over 2a is equal to the negative of negative 1 over 2 times negative 2. Negative is positive. So negative 1 is plus 1. And 2 times -2 is -4, which we can write as minus 1/4. So that's the x coordinate for the vertex. The y coordinate is f of minus b over 2a. We know minus b over 2a is equal to -1/4. So to find the y coordinate, we got to put -1/4 in for x up here. Right? Okay, evaluate this function at x equals -1/4. So we have -2 times -1/4 squared minus a -1/4 plus 1. Now you gotta be really careful of the arithmetic, okay? Because it's easy to get confused with all these minus signs when I have equal sign. Okay. Well, -1/4 squared, a negative squared is positive, and 1/4 squared is 1/4 times 1/4 is 1/16. And 1/16 times -2 is -1/8. So this is equal to, this first term simplifies to -1/8. Then we have negative of -4, or negative of -1/4, which is plus 1/4. And then we're adding 1. Well, a common denominator, right? Common denominator is 8. So we have -1/8 plus 2/8 plus 8/8. Okay? Multiply top and bottom 1/4 by 2, you get 2/8, and plus 1 can be written as 8/8. Now we combine the numerators. -1 plus 2 plus 8 is equal to 9. So the y coordinate is 9/8 for the vertex. Okay. So the vertex is at the point -1/4, 9/8. Okay? And yes, you have simplified fractions. Okay? Find the x and y intercepts. So our equation, right, if we replace f of x with y, equation is y is equal to minus squared minus x plus 1. And you know, what's the easiest intercept to find? It's the y, right? And it always just turns out to be this constant term, because when you put in 0 in for x, these first two terms are 0, and you're just left with 0 plus 1. So the y-intercept is the easiest. Put in 0 in for x. On the right-hand side, now you should be able to do this by inspection, right? I mean, just by looking at it, you can see that if you put in 0 in for x, you're just going to be left with plus 1 on the right-hand side. And so y equal to 1, or the point 0, 1, right, is the y-intercept. The x-intercepts typically that's going to involve factoring. find the x-intercepts. We set y equal to 0 and then solve for x, right? So I flipped the two sides of the equation, okay? So I'm putting 0 in for y and flipping the two sides of the equation. And I have minus 2x squared minus x plus 1 is equal to 0. Okay? I put in 0 in for y, and then I flip the two sides of the equation. Now, I hate factoring when the number in front of x squared is negative. I mean, it's a million times easier for me if this number in front of the x squared is positive. So how do I make this positive, this number in front of x squared, positive without changing the equation? How do I get an equivalent equation where instead of minus 2x squared, I have plus 2x squared? Multiply or divide both sides by negative 1, right? So if we do that, now maybe you can factor these things when the number in front of x squared is negative. You can go for it, right? But I don't find it very desirable. So we divide both sides by negative 1. The equation on the left is plus 2x squared plus x minus 1. And you still got 0 on the right hand side. Okay. Now I can factor this. Okay. The number in front of x squared is positive. So 2, right? So the factors of plus 2 are 1 and 2, right? So it's got to be 2x and x. Okay. The constant term is minus 1. So the factors of minus 1 have to be plus 1 and minus 1. But where does the plus 1 go and where does the minus 1 go? It matters, right, where you put them. And so, turns out it's 2x minus 1 times x plus 1. So if you FOIL this, okay, you end up with this up here. Okay. And so now we have product two factors equal to 0. So either the first factor is equal to 0 or the second factor is equal to 0. And so when we solve these two equations, the first one, x is equal to 1/2. So x equals 1/2 is one x-intercept, which is the point 1/2, 0 in the coordinate plane. So that's one x-intercept. And then second equation, when we solve for x, we get x equals minus 1, which is the point minus 1, 0. Coordinate plane. Okay. Now on an exam or something, typically you don't have to put both in. Don't have to express the x-intercepts in both forms, but they're equivalent. X equals minus 1 and the point minus 1, 0, right? Are the same point on the x-axis. Okay. So those are the x-intercepts. Axis of symmetry. You take the x-coordinate, you just set x equal to the x-coordinate. So x equals minus 1/2 or minus 1/4 is the axis of symmetry. Now remember, this is the equation of a vertical line. Over here where I wrote x is equal to minus 1, that's a point on the x-axis. X equals minus 1/4 is a vertical line. So in mathematics, we often use the same notation to represent different things. Okay? So you always got to know what the context is for the notation. Yes, sir.
I have a couple questions.
Okay.
Is there a particular strategy that you use when before you FOIL out, if there is like a coefficient before FOILing, like how you figured out that -1 went before +1 in that case? Is it just like
Here and here?
Yeah, is that just trial and error?
Yeah. That's how I was taught how to factor 45, 50 years ago.
And then I have.
It's just plug in and check. I mean, but you know, you learned your multiplications. You should have learned your multiplication tables when you were growing up, right? And so you're doing the multiplication and the addition in your head while you're doing that.
I had some questions about once you plugged in -1/4.
To here?
Yeah. Is the next set of work, I'm just confused how you end up with -1/8 plus 1/4. Do you end up squaring it at all?
No.
No.
You square -1/4, right?
Get 1/16.
1/16, and then 1/16 times -2 is -1/8.
Okay.
Okay. And then negative of -1/4 is +1/4.
Okay.
And then you still got the +1.
And
now you gotta find a common denominator and simplify.
Where are you saying, like, I'm confused when you're saying like it's guesswork, or you just plug it in, like, what step would that be?
Say
You said
that.
it was like guesswork, like you just plug in numbers and figure out what step would you do that?
From here to here. When I
When
factor.
you just do like negative, when you do 2, like what multiplies to -2 and then adds to 1. That's how I do it.
Yeah, I mean, if you can factor this, you're comfortable factoring this, go for it.
Okay.
Yeah,
'Cause I
go
always-
for it.
'cause my-
I'm just the way my brain works.
Yeah.
I prefer that the number from the x² be positive. Okay? Because it takes too long when you got, you know, -x, 2x, and you're trying to figure out what numbers should go there. I just have a hard time. It takes too long. This speeds things up for me by factor of 10. Okay? But if you're comfortable factoring this, where the number from x² is negative, go for it. Yeah. Just get the right factors. That's all that's important. Okay. All right. So that's the axis of symmetry. All right. The domain for all quadratic functions is all real numbers minus infinity to plus infinity. Okay. But the range, which is, remember, the domain is all the x coordinates in the graph, right? So our original function here has a negative sign in front of the x², right? Has a negative number. So here's the vertex. It's at -1/498. So it's in the second quadrant, is the vertex. Here's the x-axis, here's the y-axis, okay? And, right, so here's like -1, or here's the origin, right? So here's like -1/4, and then here's 9/8 up here. So here's where the vertex is in this second quadrant. And then because the number in front of the x² is negative, we know that the parabola opens down. Okay? So remember, the domain's all the x coordinates in the graph, and there's no minimum x coordinate, there's no maximum x coordinate, and the graph of the function is continuous, so the domain is all real numbers, from -infinity to infinity. Okay? but the range is limited. There's a maximum y coordinate, right? And the maximum y coordinate is 9/8, okay? But there's no minimum y coordinate because the graph goes down forever, okay? So the range is from minus infinity up to plus 9/8, okay? There's no y coordinate with a value greater than 9/8. So the range, and remember, you write these things from smallest to largest. So the range is from minus infinity to 9/8. Okay? The y values, the y coordinates all have a value less than or equal to 9/8 at the vertex. Okay? So the vertex, the y coordinate vertex tells you tells you what the range is. Okay. Now, if this parabola opened up instead of opening down, then the range would be from 9/8 to infinity if it opened up. Okay. All right. And I think we answered all the questions. Okay, for this example. Okay. So any questions on this? Okay. All right. So what I think I'm going to do is we get out at 10:40, and so on page 2 we do the complete square method. I think I'm going to give you a bonus. I'll let you out 10 minutes early. Okay. Because I don't want to start talking about this and then not be able to do an exam. Okay. So tomorrow we'll do the complete square method and take quiz